All right, welcome back. We're going to be jumping into the filter caps of this end of 1980, early 81 JMP 2203. You can see on here, most of these caps all of these caps have 3 terminals. They are dual caps, meaning that they have 2 positive nodes and a single negative node. So there's actually 2 capacitors in there. You can see we're using these FNTs as replacements. So it's a 50 plus 50 microfarad at 500 volt, meaning there's 2 50 microfarad caps in there, 2 positives, 1 ground, and each of those is rated at 500 volts. These ones are really great. These FNTs are a good replacement for these amps. But you can also see on these capacitors, there is a wire connecting both the positive sides. There's other wires in there. There's other connections or resistors in place, but we're going to go ahead and prep these guys before doing our install or removing the other ones by taking a piece of wire and soldering that in place on the lower side of these connections so that they're ready to be installed. It'll make things a little bit easier than doing that part in the amp. So we're going to take some of this 22 gauge wire that's rated for 600 volts. We're going to strip a long piece that can then connect the 2 positive terminals. We'll then tin that wire to make sure we have a good connection, and we're going to leave enough room at the top of these to add any other wires or resistor connections that are needed once we get this installed in the amp. So since this is stranded wire, we're going to go off the stranded side here and go to our 22 for 22 gauge. And we need about this much. And then we can twist that wire to get it a little more solid, although we will tin this as well. We can also go ahead and clip this off, make it a little easier to work with. And we don't need to wrap things all the way around, as I've discussed in other videos. Just a good quarter turn there is enough. I'm just using books to hold the capacitor in place while I solder. And we will be adding other components, so we don't need the cleanest solder joints here, so since we will be touching these up once we do our full install. So we can just clean up any extra leads. And there we go. We'll do this with the rest of these and then start installing it into the amp. The next step will be for each of these electrolytic capacitors to remove their internal connections, then unscrew the strain relief. There's a flathead connector on either side. Wiggle these loose, install the new one, and then return the original connections to the new capacitor. I've also taken some notes on the wire connections, just using shorthand that I will understand. Just in case I get distracted and have to walk away from this mid-job. Okay, I'm going to add a little bit of solder, just to help speed things along. Then we'll remove these connections. This guy stuck back on as it dried. Now we can remove the capacitor from the chassis. And we will install one of our new capacitors with the correct orientation. And once it's in place, we'll tighten the strain relief back up. Alright, so our first filter cap here on this side is changed out. We are resecured with the strain relief. It's not going anywhere. And just going to move through the rest of these in the same manner. There's also one on the circuit board here that when we get to that, I'll show you how to handle that. So we've got these 5 filter caps replaced on this side. And we still need to do the bias caps. But you can see there's one more of the large can style filter caps hiding over there underneath the board. Okay, so we've removed these 6 nuts holding on the PCB at these points, along with the lock washers that are there. Going to very carefully lift the board up, making sure to not break any of these points from the lead dress, to then just tilt it as much as it'll go to get to these solder points on the back of the board, as well as create some clearance below this point for the last filter cap. And because the spacing is going to be so tight on this, I'm probably going to have to flip the chassis on its side to look in from a vertical point of view. So I'm probably not going to be able to show this on camera, but I'll show the end result here. All right, so we've got our filter caps replaced. We've got the one under the board replaced. We've got this diode replaced. Our 2 bias caps replaced. So we're going to fire this thing up. We're hooked up to the attenuator and also hooked up to, we're hooked up to the attenuator and then to a speaker load. We've got no power tubes in place, just in case there is an issue with the bias. And then I'm going to fire it up with the current limiter for this initial check. I always do that when I'm changing filter caps or something in the power section. So here we go. Looks like the bulb came up bright and then dimmed down very quickly, so we know we don't have a short circuit anywhere, which is good. I'm gonna do left hand behind my back and measure some voltages here at the power tube sockets. All right, that's looking good. We've got bias, so that's good. That's a negative. I don't think you can see that on there. Yeah, negative 43. Okay. Everything's looking good there. This one also has bias. And the reason I'm doing this, not only on the current limiter, but with tubes pulled straight away, is to make sure that that bias current is there on all these tubes, since we did change these bias caps. If for some reason there was no bias or a much higher voltage there than we expect, higher in terms of more positive, can easily cause the tubes to get damaged, and we don't want that. Okay, so everything's looking good on the power tubes, and we can, just for peace of mind, double check that things... Now these voltages are lower than we would expect normally, since we're on the current limiter. Although maybe not in all cases, since we're also unloaded on the tubes. And I'll double check some of these preamp plates. Make sure all of our nodes for filter caps made it. That looks good. That's good. Okay, so next step will be to hook up the CompuBias with the new tubes, get things biased, make sure that it settles into place after it's been on for a little bit, and then do a little play test. Tubes are in, preamp and power tubes. You can see we're plugged into our CompuBias here, and this is a great device since it shows you both the plate voltage, the idle current, and then does a little calculation for you of the wattage. And then also has a little chart for 70% dissipation, or a range of dissipation that includes 70%, which is typical. So you can see we're a little bit low. We're running at 9.4 watts. We're running with EL34s, so we should be in the 12 to 18 watt range. I'm going to let this settle in just a little bit before I call it good, just because tube quality control is not what it used to be. It's a little bit harder unless I do recommend getting burned in tubes if you have the extra couple bucks these days, just because a lot of stuff has been slipping through quality control. I've seen a lot of tubes run away after maybe an hour or so in their first power up. But just to show you what we will do to adjust that bias, it's going to be this potentiometer right here. And I'm going to use a non-conductive screwdriver. So this is a ceramic screwdriver. In case I do drop it, we're not going to short anything out. We're going to just adjust this guy a little bit. And I'm going clockwise here. I'm going to put it into the lower end of that range. And then play the amp a little bit and see where it falls. Yeah, so right now we're sitting at about 12.2 on one set of the tubes and 12.6 on the other side. So that's kind of the minimum of where we want to be. If we want it to be a little bit hotter, we'll go a little bit closer to the 18 watt dissipation. I might even just go ahead and crank it up just a little bit more. Let's go to 15, which is halfway between those 2 points. And assuming nothing else, if nothing else comes up on this video other than a play test, you'll know that everything settled in correctly. Otherwise, I'll see you at the next part. Okay, so I do have one last note here on when I was checking the bias there was something I forgot to do. And that is these two brown wires that are coming off of the effects loop that was installed. I had to remove those in order to get the circuit board at an angle to get to the bias caps. And I forgot to solder those back on before checking the bias. Shouldn't affect anything. Yeah, and it actually still played just fine because it's just not sending the signal to through the effects loop there. And there's a switch for that, which is off. So no issues or anything, but just pointing that out in case anybody also saw those two wires just kind of floating there. But otherwise we should be good. So gonna, again, just let this settle in and we will play it for a little bit. Make sure everything's good. If there's nothing else that comes up, thanks for watching and we'll see you on the next one.